towards this computer. So we had this one from yesterday where we labeled our axes with these labels on them. We were given this description. D is equal to 60t, where D is the distance in miles that you would travel in t hours if you drove at 60 miles per hour, okay? So when we talked about independent and dependent variables, we associated them with different axes. We said every single time our independent variable or our given information was going to go on which axis? Our X or our Y? We had a rule. Every single time our independent variables or our inputs go on our, Olivia? Or x-axis. Very good. Our independent variables or our inputs go on our x-axis. So by default, our outputs or our dependent variables go on which axis? Bridget? The y-axis. Very good. So we have these guys here. So first thing we need to do with this graph is we need to identify the input variable or the independent variable. Which one of these variables, D or T, is going to be our independent or input variable? What's the button?
T.
T, which represents what?
The hours.
The time in hours. Very good. Very good. Nice job. So then our output variable or our dependent variable is going to be which one? What were you thinking, Annie? The D or the total distance. Yes, Annie. Nice job. And we gave a label of what for that? Pencils, inches, feet, what? Look back at the description. Miles. Very good. Very, very, very good. Awesome job. So now we're going to be given two different inputs and we need to calculate our output. When we calculate outputs and when we're given an input, what do we have to do with that input that we're given? We do what with it in the equation? We take it and we, what was it, Avery? Follow the rule. Billy? Oh, you had your hand up? I thought you had your hand up. No. We take that number, the input, and we plug it in. So we take this equation here. D is equal to 60 times T. And we have an input of 4. That means I'm going to put 4 in. I'm going to plug 4 in for which letter in that equation? Bridget? Oh, so let me say it one more time before you answer, Bridget. I'm going to take this 4 and I'm going to plug it into this equation where? If we know our input is 4, we're going to plug it in for what? Bridget?
T.
The T. Very good. So I could rewrite this equation. D is equal to what? 60 times 4. To get a total output of D is equal to what? 240 what? Miles. Okay? So I need you to get your calculators out. And I want you to calculate. I need you to now calculate, use this equation to calculate with an input of 7.5. Take 30 seconds right now to use your calculator and calculate that output there. Can you see now, Isabella? Hopefully. Let me try it. Okay, so we're given an input. Thank you, Isabella. Taking another 20 seconds for all folks. Calculating what that output would be when we have an input of 7.5. Make sure that you give it a label of something. Feet, pickles, pencils, cupcakes. I don't know. I'm in a food mood today, guys. Okay, let's come back together. Okay, so what did I have to do with this 7.5 using that equation? Avery.
Plug it in for T.
Very good. Plug it in for T. D is equal to 60. T, I can rewrite it as D is equal to 60 what? Avery?
Times 7.5.
Times 7.5. Very good. And I would get a total D of what? Olivia?
D equals 450 miles.
450 miles. Very good. The most important piece there is that label at the end. We're talking about miles here in this scenario. What I'm doing, I don't know. Just dancing. It's a dancing day, guys. Every day's a dancing day, though, so I don't really know what I'm saying that today is.
More dancing day when it's tomorrow because you can warm outside.
Anyway, that is our dancing for today. Let's, so we were talking about this distance that we traveled over T number of hours when we were going at a constant rate of 60 miles per hour. Awesome, awesome, awesome job, guys. Wonderful job. Let's take a look at the next piece of this here. So if you're in your slideshow, you're going to slippy slide down to slide number 2. If you are on your packet, you're still in that front page there, okay? So we're looking at that number 2 here. We're going to be using this graph and this table to answer the questions on the next slide. The thing about this graph and this table is that both this graph and the table represent the same data. So on both the graph and the table, a distance of 3 meters is going to have an output of 1 second. D represents distance. T represents what?
Time.
Time. Very good. So you are going to use this either table or graph to answer the questions on the next slide. So what I want you to do with the questions on the next slide is I want you to take 2 minutes to look at the first. You're not going to answer letter E, so you don't have to do that one, but we're looking at A, B, C, and D. I want you to use that table and the graph to answer A through D independently, and then we're going to come back together and discuss it. Does anyone have any questions on the expectations?
No.
Take 2 minutes right now to answer these 4 questions based on the graphs here.
How far are you going for 6 seconds? You just take like any time?
Well, no, after 6 hours.
Yeah.
After 6 seconds. Good question, Elizabeth. I need everyone at home to let me know in the chat that they are here. Every single person, let me know I am here because I'm taking attendance. Thank you, Isabella. Thank you, Sawyer. Thank you, Courtney. Gabby, thank you so much, my friend. So that is what I'm basing attendance on. You letting me know that you are here right now. Okay, we're taking another 18 seconds to answer those questions on slide number 3. Okay, here we go. Okay, so we were given this graph and this table here. We could use sort of either one of them to answer these questions. The first question on 3 says, how long did it take Kieran to run 6 meters? So let's see what people are thinking. How long did it take Kieran to run 6 meters? Alyssa Button, first question. Which one did you use to help you?
I used the graph.
Okay, so she used the graph. And then what were you thinking?
2 seconds.
2 seconds. And when you were looking on that graph, what did you look for?
I looked for, so I went to 6 meters, and I looked on the y-axis and see where it met at like full velocity.
Good. So she went over to 6 meters because the x-axis is talking about meters. Good. And then she went up to where it hit our line, and then she followed it over to our y-axis. That was a really good description there, Alyssa Button. And from there, she said 2, and she gave it a label of seconds. Nice job, Isabella, on that as well. Perfect. Now let's look at the second question here. How far had he gone after 6 seconds? Carter, first of all, which did you use to help you here?
I used the bottom one.
The table, okay, perfect. And then what did you get for an answer?
So I had 6 seconds as my time. So I went up to 6 seconds and 18 was the distance.
Oh, 18, what?
Meters.
Meters, okay, good. Okay, so he went in this table here. He said he went for the T over to 6 seconds. And he said, what was that D distance? 18. Grab that label of meters. Nice job, Carter. Christmas Carter is on a roll today. You're forever going to be Christmas Carter. Sorry. Okay, estimate now. So we're not going to get an exact value. So there's going to be a range here. Estimate when he ran 19.5 meters. Avery, help me out with this one. What did you use here first?
I used the bottom table.
Okay.
I saw that it was 18 is like 6 seconds.
Okay.
And so then I just figured it would be 6.5.
Okay. So she said 6.5 seconds. Because you were looking for a value where? Between the, very good, the 18 and 21 distance, so between 6 and 6.9 seconds. So I would take something more than 6, less than 6.9. So 6.5 works. What was another one that somebody else got? Did anybody get anything else? Lily? 6.3 works as well. Very good. Because this guy is an estimate. Oh, that's funny. Isabella got the same one. Nice, Lily. Okay, now last one. It said estimate how far he ran in 4 seconds. So who can help me with this one? What do we think? Bridget, help me out.
I used the table.
Okay, she used the table.
And I looked at where it was between a 3.8 seconds and like 4.6 seconds.
Okay.
That's over there.
Good.
And I got like an estimate of like 13 meters.
13 meters. Good. Because she said 4 seconds fell between on this table where our T was between the 3.8 and the 4.6. So she said some number between 12 and 15, 13. Did someone get a different answer there? 13 meters. What else do people get for answers here? Olivia?
You can also get 13.5.
13.5 meters. I like it. Very, very, very good. Nice job. Somewhere between that 12 and 15. I probably wouldn't accept 12. I wouldn't accept 15. So somewhere in between that. Nice job. So we're not going to look at this E here because we're going to touch on that one back at the end of this activity today. Okay. So if we have time, we're going to circle back and answer some questions about Freya's running. But I want to do some of the other activities first. So if we have time, we'll come back. But if we don't, that's okay. So where I want you guys to skip down to, on the slideshow, I want you to go to 7. If you're in the packet, you're going to go to the one that has the 2 tables on it. Okay, it's going to be when you flip, you're going to have flipped your packet, and you're going to be in on the back page of that first page. Okay, and it says use the table of values to calculate and write a rule for the functions. So you have 2 of these. You have 2 on 7, and then we have 1 more on slide number 8. I'm going to give you a minute. I'm going to give you 2 whole minutes to look at all 3 of these and try to calculate a rule. The first 2, it's going to be a 1-stepper. Taking 2 minutes, let's get started. Friends at home, we are looking at 7 and 8, and we're going to try to calculate those rules. 7, both of those are going to be 1-steppers. 8 is going to be a 2-stepper. Take 2 minutes right now. Let's get started. Billy, Julie, Alyssa, LAC is not here. Okay, so my friends at home, once again, you need to tell me in the chat that you are here because that is what I'm basing attendance on. I got one from Gabby, Courtney. I got one from, let's see, Isabella. I need everybody else to give me something in the chat that they're here. Thank you, Jaden Ramos. Hey, that means I haven't heard from Allie Caros. I haven't heard from Isaiah. I haven't heard from Diego. I haven't heard from Faith, and I haven't heard from Kyle. Wonderful, wonderful. We're taking another 27. You guys are doing great. We're doing a lot of independent time today. Okie dokie. Okay, corral. You don't know what, Kyle? You don't know if you're here? Because that's literally all I'm asking you. Is are you here, Kyle? That's all I'm asking you. Okay, let's take a look here. So now we're looking at this table here. That tells me you're not paying attention, Kyle. So let's be really focused, okay? So we're looking at our inputs and outputs here. What are we doing to these inputs to get these output values here? What did we think the rule was going to be here? Olivia, what were you thinking here?
I said square the number.
Square the number. Okay. Does anyone have a different way of saying that? I like it. Is there a different way that we could say that, Tiana? Multiply it by itself. Very good. These two sentences here, these two descriptions mean the same thing. What if I wanted to simplify it and just write down like mathematically, what do you have to do? Like x plus 7 or 3x. How would I write this? What is the mathematical operation instead of writing it with words, with symbols? Olivia.
You can write x with an exponent.
X with an exponent of 2, good. Or you could write it as what times what? Olivia?
X times x.
Or you could write it as x times x. Here's the deal. I'm not trying to complicate it. I just want you to be aware that sometimes these rules can be written in multiple ways. And if you write it x times x, you're just as correct as if you were to write it out as a sentence like this. If I wanted you to write it like one of these two up here, I would have to be more specific in my directions and tell me what is like the rule written in with mathematical symbols, would be how I would ask you if you had to write it like this. Okay, good. Very good. So now what's our rule? Looking at this second one, what did we think the rule was going to be for this one? Ooh, Lily.
Divide the input by 2.
Divide input by 2. Do we agree
Yes.
or disagree?
Okay.
Alyssa says agree.
I agree.
Olivia says agree. Who else agreed? Avery agreed? Very nice. Carter agrees as well. Christmas Carter. I agree as well. Is there a way that someone else wrote it as opposed to a sentence with words? Is there another way that we could write this? There's a couple other ways that you could write this. What do you think, Alyssa Button?
Did you write it as like split the number in half or no?
Yeah, you could say split the number in half. That's another way of writing it. Good. Lily, what were you thinking?
Like a fraction, like input over 2.
Or you could write it as input over 2. Good. Because remember, division is same thing as a fraction. Nice job. You could write it as x over 2. That means the same thing, x being your input value. You could say divide by 2. Once again, I wrote a lot of different ways down here just to show you that there are multiple ways of saying the same thing. Okay? Very, very, very nice. Okay. Now, let's move forward to that trickier two-step problem. Slide number 8. We have some input values. We have some output values. We had to look at this guy and we had to think. Leah, what were you thinking when you looked at this one here? Did you notice anything at all?
I don't know.
Well, let me ask a clarifying question. When we look at our inputs and compare them to our outputs bigger or smaller?
Bigger.
They're getting bigger. Yes, good observation. Very good. So we're saying they're getting bigger, so we might have to do what or what? Go ahead. Multiply or add. Good. So Olivia, what were you thinking the rule was going to be here?
I said multiply by 3 then add 1.
Okay, multiply by 3, then add 1. Can I get some thumbs up if you agree? Some thumbs down if you don't necessarily agree. Okay, I see Avery, Lily, Alyssa Button agrees. So does Billy, so does Tiana, so does Kaylee B, so does Annie. Jonah, what are you thinking? Christmas Carter agrees. Oh, no, Mr. Carter doesn't agree? Not sure?
I'm not sure.
Not sure. Brandon, did you agree or no? Or we were like, I don't know? No, you don't know? Okay.
Actually,
So multiply by 3, then add 1. Let's test it. So let's take that first input and do what it tells us. We have an input of 1. First it tells us we have to do what? Multiply by 3 to get 3, and then add 1 to get 4. Oh, that worked for the first one. Let's test it with the second one. An input of 2, we do what to it? Multiply by 3 to get, and then we add 1 to get 7. Are we right?
Yes.
You're right.
duh.
Nailed it. Very good. So we had to multiply by 3, then add 1. My suggestion to you, if you are asked to write a rule given a table, make sure, test a few of them to make sure that it works like we did here. Okay? Hey, awesome job, everybody. Now, this one's probably my favorite. We are given a rule and a function machine and some inputs, and we have to calculate some outputs. First thing I want to do before you get started, because I know you guys are going to do well with this. First thing I want to do is I want to label these parts of the function machine. If I look at this middle section here, what is that called? What do we call that piece that's in the middle? Billy? The rule. And the rule is what? Billy?
It explains what you're gonna do to the input.
Good. It explains what you're going to do to that input. Very good job, Billy. And so the left side of this function machine, we have our what? Olivia?
Our input.
Our input. Very good. Another word or phrase for input is our what? Given number. Very good. Our given information. And the right side, which you get out of that rule, is called our what, Tiana? And another word for that is our answer or our solution. Very good. Yes, Tiana. Nailed it. So now what I want you to do, I want you to take 1 minute right now to do some calculations. Look at this rule here. Given these inputs here, I want you to calculate what your outputs are going to be. If you finish early, I want you to take a look at the rule on slide 10. Hint, 10 is a little bit trickier. Let's take 1 minute right now. This is Mr. Main. Hi, Tara is down in wait, let me think. Yes, so she is, if you call, she should be in 334. Yep. Yep, 513. Yep, 33. Yep, 4. Yep, no problem, Ramadan. Bye-bye. Oh, he's asking me. I don't know. You didn't know how to call people until 2 weeks ago. And I've been here for 2 years. Okay. Very good. So our rule is multiply by 2, then add 3. So I have an input of 1. I'm going to first multiply by 2, then I'm going to add 3. What do we get for an output here? Olivia? 5. Very good. Anybody disagree? No. Very good. Ethan, I have an input of 2. What's my output going to be? Multiply by 2, then add 3.
So it would be 4, but then add 3.
Yep.
7.
7. So this needs to be filled in on your slideshow. You shouldn't be like, you don't need to, you can just tell me what the final answer is gonna be. You should have already this written down. Tiana, I have an input of 3. What am I gonna get for an output? 9. Do we agree?
Yes.
Very good. First we multiply by 2 to get 3, or to get 6, and then we add 3. Very good. Input of 5. What are we gonna get for an output? Oh yeah? 13. What do we think? I love it. Nice job. Fantastic. Last one here. An input of 10 is going to give me output, Billy, of 23. Kaylee B, what do we think? Agree? We agree? Very nice. Look, I thought I was going to trick you guys. What the what? Hi, this is Mr. Main. I do, yeah. Yep, no problem. Thank you. Billy, you want to go down to guidance for me? Miss O just wants to talk to you for like 30 seconds. I don't know why. Very nice. Now, this is where it gets a little bit tricky because now we don't have the exact, like, you need to do this times this, then do this. It's now sort of like a story. We need to calculate the perimeter of a square. So let's think, let's go back into our repository of our brains. How do we calculate the perimeter of a square? Oh goodness.
Wait,
What's fun?
isn't it length times
Perimeter though, not area,
Oh,
not times. Olivia?
you add all the sides.
You add all the sides of a perimeter to get the perimeter. Good. And if we're talking about a square, we know all the side lengths, Olivia,
Are the same.
are the same. So we're going to be able to say side plus side plus side plus side, right? 4 side lengths added together is going to get me the perimeter of that square. Is there another way that we can write this? A simpler way? Elizabeth?
Could you do x times 4?
You could say S times 4. Very good. It's gonna mean the same thing. You add that side length 4 times, or you could multiply that side length times 4 because we have 4 of them. 1, 2, 3, 4. Very good. So now if we have an input of 1, and our rule is S plus S plus S plus S, or 4 times S, what's it gonna get for an output? Olivia.
1 equals 4.
It's going to get me an output of 4 because 1 times 4 gets me 4. Very good. Now we have an input of 2. What is my output going to be? Annie? 8. Do we agree? Very nice, Annie. Very good. Now we have an input of 3. Jonah, what are we going to get for an output? 12, because we multiply that input times 4 to get 12. Very good. Ooh, now we're going a little bit further. An input of 5. Ooh, Tiana's ready. What's going to be?
20.
20. Very good, because we do what to get that value? Multiply by 4. Woo! And then lastly, a side length of 10. Avery?
40.
It's going to be a 40 centimeter or whatever perimeter. Very good. Ooh. You guys are fierce. I thought I was going to get you. I wrote that one intending to trick you, but it didn't work. Right there. Okay. We're going to do one more before we head down for our math break. So we're going to go to slide number 11. Okay, we're given a graph here with some data on it. Okay, on what day or days, what's in parentheses like that, it means it could be more than one. Did the temperature hit exactly 60 degrees? Take a second, and then Alyssa Button's going to help me, but let's take a look first for a minute. Exactly 60 degrees. Alyssa Button. On what day or days did it hit exactly 60 degrees?
On day 1 and day 7.
Day 1 and day 7. Okay. And how did you know that?
Because I went over on the y-axis, I looked at where like the 60 degrees was, and I went over on the x-axis to find like where exactly it hit between 4 dots
And it hit on day 1
and day 7.
and day 7. Very good. So she looked on the y-axis because the y-axis talks about what?
The degrees.
The degrees. Very good. Nice job, Alyssa Button. Fantastic. And I love that explanation as to why you did what you did. The talking and you giving the names of the axes was probably the most amazing part. Next question. What was the temperature on day 9? Lily knows.
67 degrees.
67 degrees. And I love that you said degrees. How did you calculate that?
I just looked on the chart.
Where did you go over? Did you go over to what? Where?
Day 9, and then I went up to
Yes, that's so good, Leah. She said she looked on the x-axis here because it's talking about days. She went to 9. She followed it up to where the dot was, brought it over to our y-axis, which was 76 degrees. Nailed it. So good. Scary good, actually. Next question, last 2 questions before we go down. On what day or days did the temperature hit 63 degrees exactly? Tiana, help me out.
Day 3 and day 10.
Day 3 plus day. Okay. So who can tell me that somebody agrees with this? Tell me, how did we get day 3 and day 10? Go ahead, Bridge.
I looked on the y-axis and I looked at all the points on that were on the 63 line.
Good. And you found it hit on day 3 and day 10. Yes, very good. We look on the y-axis for the 63 because that's where our temperature is talked about. Last question. What was the temperature on day 5? Avery.
62
62 what? Pickles?
degrees.
Oh, degrees. 62 degrees. Very good. And how did you calculate that, Avery?
I looked on, don't give me that look, Bridget. I looked on day 5 and I went up to the point it was on in the 62.
Which axis talks about days, though?
I was on the x-axis.
Oh, over the 10, over the 5, up to where it hits the point. Good, nice job. Oh, hi, this is Mr. Main. Yes, I can come on down. Wonderful. Wonderful. Okay, so guys, we are going to listen carefully. We're going to get ready for our math break. My friends at home, your homework for this evening is slide number 14. Miss McCain is going to come in if you want to take a look at 14 now. I'm going to run down. I have to log in my computer, then we're going to head down for our math break, okay?
My computer is weird. You know how it locks me out every morning? So in there, so I called the tech guy, and then he came in there, and it worked in there, and then he looked at me like I was crazy and I was making up. But you guys see it every single day.
Well, I think it's because Mr. May is like, I think a lot of people put Windows on his computer. She's checking the.
It's like just because that's a different like login than the Google. I don't know. All I know is you guys have seen it happen every single day. On the first time I try to log on, and I am not.
I want my attorney on the site if we're gonna have to try them.
Yes. We're gonna record me doing it next time.
Okay, I got it. I'll record it.
Log in.
Don't need that for you. I don't need it right now.
Easy.
Don't.
What is this?
Don't.
Oh.
Okay, ladies and gentlemen. Yeah, we're gonna go mass break right now. Homework for this afternoon is slide number 14. We're going through it tomorrow in class.
Where do you want me to put this?
If you didn't use it, you can throw it right on that desk right there. I'm gonna throw people at home in the waiting room.
Oh, wait, Miss Jane, what happens if you did use the paper? Do we have to write everything down in the slides?
Yeah,
Oh, wait, what?
I mean, it's not like as you know, I don't check the slides, but I give the paper just because
Okay.
like I personally like to write things out and I like to have a space to do the math out. But if you don't want to do that, then that's fine. Okay, let's head down for our mass break. You guys can line up at the door. You guys can head down for our normal class.
I can make it a problem so it won't die, but I will do my best.
Alright, guys.